So in this class we shall discuss Physics Chapter 3 Current Electricity Part 4. Part 1 to 3 I have already discussed and uploaded in the YouTube. I have sent you the link. So you need to be more familiar with those 3 parts, only then your concept can be more clear in this 4th part, okay? Otherwise we'll have some difficulty. If we have some difficulty, we'll go back. It's no problem, okay? So in this topic, part 4, I want to discuss about the cell, the EMF. These things you have studied in class 10. What is the cell energy? What is EMF? Okay. Internal resistance. This can be new for you. Today, in today's live class, I could only discuss cell and EMF. EMF only, I don't think I could complete EMF also. I didn't put the definition also. I was just explaining the function of the cell with the help of chemistry. At that time, everything went chaos. Internal resistance and terminal voltage. This is new for you. Terminal voltage is not new for you, but the name is a bit different here. You will get to know it. Internal resistance, this is something new. Resistance, of course, is not new for you, but internal resistance is something new. Cell and EMF, you are very familiar with it. Okay? Now, after we understand the function of the cell, only then we can define EMF. Okay? So when we talk about cell, in biology, cell means the smallest organism, right? But in physics, it's a device. When you connect a cell to an electrical circuit, then the current starts to flow. That means we used to think that people usually think that students, they think that we think that the cell provides electric charge. Electric charge means electrons, right? So that's the misconception, okay? But what cell does is it never produces any electric charge on its own. Okay, it never produces. So cell, they do not produce any charge. That means they don't produce any electrons. Charge means it's a fundamental particle. It cannot be created, nor it can be destroyed, right? So a cell cannot produce a charge. Is it okay? Charge means it should exist by itself. Alright? Yes. I think I have put on the video, no? Yeah. If a cell does not produce any charge, then what it is? See, we connect a cell to an electrical circuit, then there is a flow of current. So we think that cell is producing charge. Means it is producing electrons, but that's not true, right? Then what does it do? It provides energy. What energy? Electrical energy to all the components of the electrical circuit. In an electrical circuit, we have resistance. We can connect a bulb in a circuit. We can connect a fan. We can connect a TV. We can connect a refrigerator. Anything can be connected in an electrical circuit. Okay. So cell provides energy to all the components of an electrical circuit. Okay. So, and we are going to learn how. Okay. See, in class 12, you have, I think, in your chemistry, you have electrolytic cell. Have you studied that part? Electrolytic cell, the simplest example is galvanic cell. In class 10, did you study about the dry cell in science, in electricity? Yeah, but I don't think much in detail also. No. Yeah. Okay, we are going to have a few highlights on that. And in class 12, you will learn better in chemistry. In electrochemistry, there is a chapter, electrochemistry. Under that, you have a topic, a small topic, electrolytic cell. That's the entire mechanism of the cell is given. Okay, if you can understand that, then understanding cell would be of no problem. Okay, so they do not produce any charge, but they only provide electrical energy to all the components of an electrical circuit. So cell provides electrical energy to all the components, of an electric circuit. In this chapter we will also learn how to draw different kinds of electrical circuit at the end of the chapter. And there is some technique, you can solve any kind of electrical circuits. There is a logic behind it that we will do later on. The third one is, we are saying that cell provides electrical energy to all the components of an electric circuit. You see, suppose this is a cell. Okay? These are the two terminals of the cell. Across these two terminals, I'm going to connect a resistance, an external resistance. Okay? This resistance is connected outside the cell, so external resistance. Okay? Now see, what does cell do? Cell maintains a potential difference. The potential difference is the setup volume. Okay? Which forces, due to this potential difference, so cell maintains a potential difference, which forces the electrons to move through the electrical circuit. So cell maintains a potential difference, means the positive potential is always higher than the negative potential. So the electrons flows in this direction, from negative to positive. Electrons flows from negative potential to positive potential, from lower potential to higher potential. Then current always flows in the opposite direction, in a direction opposite to the flow of electrons. Is it alright? Yeah, we used to think like where the electrons are going, current is going, right? Electrons means flow of current. We think that no, but that's not that true. Okay. So since cell maintains a potential difference, which forces the electrons to move through the electrical circuit. So if the electrons move from negative potential to positive potential, that's how electrostatic works. Now, electrostatic works that way. The direction of the electric field is from, electrons will move towards the positive terminal, right? That's how electrostatic works, okay? Yes. Whereas electric current flows in a direction opposite to that of the flow of electrons. That means cell maintains a potential difference. Not just a potential difference, it tries to maintain a constant potential difference. Any constant maintain it accordingly. Which forces the electrons to move in an electrical circuit. Is it okay? This circuit means not like online circuit, electrical circuit, okay? Okay. Now see. So according to this, what is clear now? Cell provides energy to the electrons. Electrons, after gaining that energy, they will move through the electrical circuit. As these electrons, with that energy, once they crosses resistances. Resistance means you can connect a bulb over there, a TV, a refrigerator, a light, anything, an electrical heater, any electrical gadget. Okay, resistance means. So electrons, after gaining that energy, they move, through the circuit. And as these electrons crosses through this resistance, they lose their energy there. That energy lost in the resistance is being converted to light energy, heat energy. Is it okay? Mechanical energy and so on. Once the electrons drops their energy here, they will come back to the cell again. The cell will again provide energy, and this process keeps on continuing. Is it clear? That's how cell works. Okay? But let us go deep inside. Like what actually happens inside the cell. Okay? Was this clear in today's class? Was this clear in today's class?
First and second one.
Oh, first and second one only. Oh, yeah. But the attendance was very good. I think 69 out of 16. Enrollment was 69. I think 65, 66 students attended now. So in the enrollment was fun. Let us do some chemistry. A little bit, okay? A little bit. I cannot discuss much in detail about those electrochemistry, but so I think Dr. Sanen will work out with that. Then you will understand your battery mechanism, cell mechanism will be very clear to you in that case. Now, let us see what is electrolytic cell. Electrolytic cell. In chemistry, you have a chapter, electrochemistry. There you are going to study a small topic over there, electrolytic cell. And this explains to you the entire mechanism that is going on inside the cell, okay? Every reaction that is taking place inside the cell. How is the cell acquiring energy? Now, how are they moving from one terminal to another terminal? Is it okay? Everything will be clear to you here, but I'm going to highlight a few here. In electrolytic cell, chemical energy, was this part clear in today's class, or it was not visible? Yes, okay. Okay. In electrolytic cell, chemical energy gets converted to what? In chemical energy gets converted to electrical energy. Okay. That electrical energy or chemical energy gets converted to electrical energy. The cell provides this energy to the electrons, and the electrons will flow, will move through the circuit. Is it okay? With this energy. Alright? Yes. Now, the simplest example of electrolytic cell is your galvanic cell. Galvanic cell. Is it okay? Let us try to understand this. Suppose in electrolytic cell, what do we have is, we usually have a container fitted with two electrodes. You know what are electrodes? In class 10 science, you have already learned this kind of things. Okay, we have a container in which two electrodes are fitted. Electrodes means what? They are usually metallic rods or metallic plates. Okay, two electrodes, two metallic plates. Now, these two electrodes are dipped in a solution. In a solution known as electrolyte. This electrolyte, okay, this electrolyte is a solution which conducts current. So this electrolyte is a conducting solution. Conducting solution. That means it has ions. Ions, okay. So ions থাকিলেহি electricity to conduct করিব. Is it okay? Huh? Yeah, if a solution has no ions, then it cannot conduct electricity, okay? Yeah. So is this clear with you? No? There is a small arrangement in which a small container in which two electrodes are fitted. Electrodes, they are like what? Metallic rods, metallic plates. These electrodes are what? Immersed in an electrolyte. Electrolyte means it's a solution which conducts current. So this electrolyte means conducting solution. Is it okay? So the chemical reaction taking place inside the cell. This is what is inside the cell. So the chemical reaction that is taking place inside the cell is known as what? What is the chemical reaction that takes place here, that is taking place here, that takes place inside the cell? Exothermic. You know what is exothermic? Exothermic redox reaction. So the chemical reaction that takes place here inside the cell is known as exothermic redox reaction. Now, you know what is redox reaction? Okay. In redox reaction means a reaction in which both oxidation and reduction takes place. Very simple. Exothermic means energy is released. Okay, energy is released. Energy is released. Redox reaction means both oxidation and reduction is going to take place. That means in one there are two electrodes. In one of the electrode, oxidation will take place. In the other electrode, reduction will take place. The electrode in which oxidation will take place, negative charges will accumulate there. Means electrons will accumulate there. And the electrode in which reduction takes place, positive charges will accumulate there. Positive ions will accumulate there. Okay? So let's say that in this electrode, oxidation takes place. So there will be an accumulation of negative charges, means electrons will accumulate here. Correct? In this electrode, reduction takes place. So positive charges will accumulate here. So what has happened? A potential difference has been set up across the two electrodes. This electrode has positive potential now. This electrode has negative potential. So the potential difference across the two electrodes will be higher potential minus lower potential. So a potential difference of this much volt has been set up. Is it okay? Yes. Due to this difference in potential, okay, before that, you connect the two electrodes with a wire provided with an external resistance R. Is it okay? Now what will happen? Due to this difference in potential, electrons will start flowing from the negative terminal to the positive terminal. Is it okay? Electrons, when they flow from negative terminal, they have like excess amount of energy. As they crosses this resistance, they lose their energy there. Is it okay? After losing that energy, they come to this positive terminal. But that's not the end of the journey. That's not the end of the journey. If the electrons, okay, ends their journey over this terminal, then the circuit is not complete. In order to complete the circuit, electron has to move from this positive terminal to negative terminal. Only then the circuit is complete. Otherwise, see, if the electrons do not move from this terminal to this terminal, the circuit is not complete, right? Is it okay? Yes. Now, if this is clear to you, then you see, if you just take out a negative charge from this electrode, electrons, they are going from this positive terminal to negative terminal. Is that against electrostatic? Oh, that's against electrostatic. This is a contradiction to electrostatics. Actually, according to electrostatics, if you take out an electron from here, then it should move towards the positive terminal, electrostatic force. But, right? But see, only if the electrons goes from this positive terminal to negative terminal, only then the circuit is complete. That's logical, but it is true only. Okay, it logically as a circuit complete हो बोले electrons to positive pra negative terminal भी जा बोले लगे. less circuit complete hobo the logical holy. That is the thing which is true here. Okay, electrostatic works is not going to work here. See, outside the circuit, in the external circuit, electrons are flowing from negative terminal to positive terminal. Electrostatic is true here, but inside the cell, electrostatic is not working. Is it okay? Yes. So the electrons, they have to move from this positive terminal to negative terminal, only then the circuit will be complete. Now if you take out an electron from this, okay, from this electrode and let it go, then it will have a tendency to move towards this positive terminal, right? Now, electron ita ulai dibi na. To ki hobo? It will have a tendency to go towards this positive charge, towards the positive terminal, right? Electrostatic force. Is it okay? Yes. But instead of that, the electrons are moving from positive to negative terminal. Okay? So that means the electrons, as they are moving from positive terminal to negative terminal, the force experienced by the electrons, okay, in this journey is non-electrostatic. Are you getting me? No? Yes. Now, but how can the electron move from this positive terminal to negative terminal? No. Now, I think lots of work has to be done. Now, only if you do some work in order to pull the electron from this positive terminal to, from this, now, if you do some amount of work to pull the electron from this positive terminal towards the negative terminal, only then only then it can come, right? Otherwise, if no work is done, then all the electrons will start accumulating here. Is it okay? And there will be no motion of electrons from this positive terminal to negative terminal. So in order to make the electrons move from this positive terminal to negative terminal, some work has to be done. That work is being done by the cell. Is it okay? That work is being done by the battery. So that's the battery mechanism. It can become battery mechanism. Alright, that's battery mechanism. Is it okay? We are not going to go in detail about the battery mechanism. We are not going to discuss the chemical reaction that is going on inside there. That is not a part of our chapter. Okay. In physics, what we all need to understand that due to battery mechanism, electrons are being pulled from this positive terminal to negative terminal. Only then the circuit will be complete. And during this journey, the electrons gains a large amount of energy. Is it okay? From where? Exothermic. Now, this is an exothermic reaction. Energy has been released. Now, so during the journey of the electrons from this positive terminal to negative terminal, they gain a large amount of energy. Okay, an adequate amount of energy. After gaining that energy again, they will move through the circuit, through the external circuit. As they pass through the resistances, they will lose their energy there. After losing that energy, they will come back to this positive potential. Again, the battery mechanism will pull the electron from this positive terminal towards the negative terminal. During this journey, they will acquire energy. They will gain a large amount of energy. With that energy, again, they will move through the external circuit. So this process keeps on continuing. That is how things goes inside the cell. That is how things goes inside the battery. Is it okay? And the force with which the electrons are being pulled from this positive terminal towards the negative terminal is your non-electrostatic force. Is it okay? And that force is being offered by the battery. Now, battery do some work. Battery battery has to do some work, has to do a lot of work so as to pull the electron from this positive terminal to negative terminal. Otherwise, it is not possible. Is it okay? That's your battery mechanism. Due to some battery mechanism, electrons are being pulled from the positive terminal towards the negative terminal. During this journey, they acquire a large amount of energy. Is it okay? And from where are they acquiring that energy? It's an exothermic reaction. Lots of energy are being released. That energy is acquired by the electrons in this journey. Okay? Once they acquire that energy, they will move through the external circuit, drops their energy, loses their energy when they crosses this resistance, again reaches the positive terminal. In the battery, due to battery mechanism, again the electrons will be pulled. So this takes place inside the cell, and this is the function of a cell. Are you clear? Yes, when you study chemistry, things will be very more clear about the battery mechanism. Okay? Only in one book of physics, they have mentioned about this battery mechanism, but they have not given in detail. Okay, they have touched only the surface. That is class 12 physics by Verma, S.C. Verma. Only in that book, you will find this word battery mechanism. Okay, so battery mechanism to क्या से बोले? This, according to the battery mechanism, the battery has to perform some work so as to pull the electrons from this positive terminal to negative terminal with some force, which is non-electrostatic. Okay, and during this journey, they acquire energy. After acquiring that energy, they will move through the external circuit, loses their energy as they crosses through the resistance, comes back to this terminal. The same thing again. It keeps on happening. Is it okay? Yes. Till all the energies are being utilized. Once the energies are being, all the energies are being utilized, time to change the electrolyte. Is it all right? Yes. In your dry cell also same mechanism. Okay. We use different kinds of electrolyte in different cells. Okay. Is this clear to you? Yeah. Any questions that you want to ask relating to the cell, the function of the cell? Anything which is not clear to you about what is cell and about the function of the cell?
Sir,
Yeah.
bigger cells means more energy.
More electrolyte, yes, more electrolyte. More the electrolyte, more energy will be released. Is it okay? Yes. It all depends upon the amount of electrolyte, the type of electrodes present in the cell. Yeah. This is a simple example of a dry cell. It's the simplest cell, galvanic cell. Yeah.
So when we say a battery dies out, that means it has lost its
All its
capacity to
energy
do-
are
to
being
work-
used up now.
to do the work.
Yeah. If all the energies are being lost out, then the electrons do not have sufficient energy to move from this terminal to this terminal. No? Yes. In that case, if the electron stops flowing, current also stops flowing. Is it okay? So at that time to buy a Duracell battery.
Potential difference, higher difference
Yeah.
minus the lower difference.
Yeah. Higher potential minus lower potential. That's your potential difference.
2V.
Yeah.
Yes.
Higher potential minus lower potential.
2 volts.
So 2V. Okay, this can be 10 volt, this can be 2 volt. Is it okay? Something like that, okay? Yeah. Now let us try to understand what is this EMF. Have you ever heard about the word EMF? In class 10 you have heard the EMF, okay? It's just that it's been 2 years now, so you are forgetting things, okay? And if your science teacher was good enough, then I think these things should be very clear to you, okay? Okay. EMF. Name is electromotive force. Electromotive force. But it is not a kind of force. But see, according to the word electromotive force, so we will think that like this is some kind of force. But this is not a force. Is it okay? Earlier, they had misconception those Isaac Newton and all these things, maybe they had misconception that this was some kind of force. So they give the name as electromotive force. So it's just the historical naming. Historical naming. The history but it is not a kind of force. Okay, maybe they had misconception that this was a force, so it's electromotive force they gave according to that. So that's historical naming. Like, see example, if a person is named David, okay, yeah, and if he starts robbery, criminal, is it okay? If he like abusive to alcohol and these drugs, still then we cannot change his name, right? Because his historical name is David, he is named David, so nothing can be done. The same way, okay? Yes, name was force, but just the historical naming, so we cannot change the name now. No? Yeah. Now see, in a cell, we now learn that a potential difference is set up across the two electrodes, right? Now, so, what is the potential difference between the two electrodes before you start to pass any current in the circuit? That is known as electromotive force. Are you clear with that? So every battery, no? When you buy a pencil battery every day or Duracell, everything, a small one, a pencil battery, its EMF is written to be 1.5 volt. Bigger one, okay, bigger one. Bigger one will be like 3 volts, 3.0 volt. What does that mean? This means the potential difference between the two electrodes before the current starts flowing in the circuit. Now, so this difference in the potential between the two electrodes before the current starts flowing in the circuit is known as your electromotive force. Is it okay? Yes. Is it clear to you? Now, the potential difference between the two electrodes in an open circuit. In an open circuit means before the current starts to flow in the circuit is known as electromotive force. Can I write that? Now I'm going to give a very good example on this one. The potential difference between the two electrodes. Between the two electrodes in an open circuit. In an open circuit. Open circuit means before current flows in the circuit. Okay? Current to flow no gravity. Now, switch to open tagadamdi. Switch open means you are not sending any current to the circuit, okay? Current flow no gravity, that means switch to kuligena tagadamdi, open tagadamdi. What is the potential difference between the two electrodes? That is known as EMF. Okay? Voltage. Battery laga voltage. EMF ko itoki. No? Acha. To ityado. Let's go and buy some battery and let us do some experiment, okay? Let's do some theoretical experiment. Suppose you went to the market, you buy a battery, okay? You buy a cell. So the cell that you have bought, let me only draw the symbol. How do we... Know the cell though? Okay? You bought a cell and it says that it's written there, the potential difference between the two electrodes is 12 volt, okay? They won't lie, no? The company won't lie. The smallest one will be 1.5 volt. I'm buying a little bigger one, maybe a bike battery, no? Okay. Arido. Across the two, this is inside, no? So across the two terminals of the cell, you connect an external resistance. Okay? Suppose this resistance is like 4 ohms. Say. This resistance is 4 ohm. No? And you need to know how much current will pass through the circuit. For that, you connect an ammeter here. Ammeter should always be connected in series to the circuit. Okay, I think you know what is series and parallel now? Yes. What is ammeter here? Ammeter is an instrument used to detect current. Is it okay? Galvanometer can also be used to detect current. Oh yeah, if practical starts, then things are going to be very interesting. Okay, you'll be doing with all these devices, dealing with all these devices. Very interesting. The difference is that galvanometer means even the presence of slightest current can be detected, whereas ammeter cannot detect presence of like small current. Okay, that's the difference. And I want to measure the potential across this resistance. For that, I need to connect a voltmeter. 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 Voltmeter means an instrument used to detect the potential difference. So across this resistance, I want to find out what is the potential difference. In a battery, it's written the EMF of the cell, right? Potential difference between the two electrodes, 12 volt, 1.5 volt. We are going to experiment whether it is true or not. Okay, yes. Whether the company is lying or not. So, in order to, that means according to our observation, according to theory, EMF of the cell must be equal to the potential of the cell must be equal to the potential across this resistance also, right? Right? No? Inabahubo lagi do. So in order to measure the potential across this resistance, I have to connect a voltmeter. But how do you connect a voltmeter? In parallel. Always in parallel. Okay? And ammeter in series. Otherwise the circuit, there is an error in the circuit. Okay? Yes. During activity in your physics practicals, what we do is the teachers will just make up a circuit. We will do wrong arrangements, and the student will be asked to correct it. Is it okay? Yeah, especially during the viva for the activity, no? We do that. So, ammeter always in series, voltmeter always in parallel. Let's see. Potential of the battery is 12 volt. Company. Resistance is 4 ohm. No? Shall we see how much current is flowing in the circuit? Ne? Okay. So according to Ohm's law, V is equal to IR. No? Potential of the battery we used to write as EMF E. Okay? Or for now you just write V, no problem. Okay? V is 12 volts. Current is what I want to find out. Resistance is 4 ohm. So the current will be equal to 3 ampere. So 3 ampere current is flowing through this circuit. That's what you think. That's what you think. Okay. Correct. Current means ampere. So this is your thinking, theoretical thinking. This is what you believe. Or not believe, this is what you expect. Let's see what is the real observation. Asli to kya sahi itya chani. Okay. No? Silul, any problem? I think you are still with this one. Okay. Now what I'm going to do is the same battery whose potential is 12 volt. Okay, no problem. I'm going to connect the same resistance across 4 ohm. Is it okay? Yes. अच्छा तो ये लगा potential भी किमान होगा. Current तो ये current किमान आहे से, ये current किमान आहे से. 3 ampere current आहे से ना. तो ये ला potential विचारिबो ने. Potential drop or potential difference across 4 ohm resistor. According to Ohm's law, V is equal to IR. How much current is coming through this resistance? 3 ampere. How much resistance? 4 ohm. 12. It's okay. Here also 12, here also 12. Okay, true. That's what we expect. It's complete observation. This is the ammeter, a voltmeter I'm going to connect here. Now you see, when you connect the circuit to an ammeter, you observe that instead of 3 ampere current, the battery is only sending you 2 ampere current. Okay. Ito time dito ammeter hakanay ko no? Kadito na calculation. But once you connect it to an ammeter, you now find that instead of 3 ampere, that's what you were expecting, the battery is only sending 2 ampere current. Is it okay? And if the battery is sending only 2 ampere current, let's see what is the potential across this resistor. According to Ohm's law, V is equal to IR. Current is 2 ampere, resistance is 4 ohm. 8 volt. Battery, company says battery, potential of the battery is 12 volt. But experimentally, we have verified that there is only a 8 volt potential in the external circuit. No? That means the company is cheating 4 volts on us. That's what we think now. So where does 4 volts go? Battery is 12 volt na potential. Nano way. Olivia amikhan external circuit connect kora pichedido potential do 8 volt ya hesedo. Asal do 12 volt hobo lagedo na. Nano way. That means there is 4 volts missing. There is a potential of 4 volts that is missing. So where does this 4 volts go? That is what we are going to discuss. Is it okay? Are you getting this? No. Electrolytic cell diparbanawani akilakani. Let us draw that electrolytic cell. Or if this is this done, let me draw over here because if I go there, my shadow appears on the board. So this is too long. So you have 2 electrodes dipped in an electrolyte. Okay, we have an electrolyte here. Now you already know what is the battery mechanism. The battery works in such a way that electrons are being pulled from this positive terminal towards the negative terminal with some force. That force is non-electrostatic because it's going against the electrostatic force, right? Yes. And that was a contradiction to the here the electrostatic force outside. Inside non-electrostatic force. That force led to kind of contradiction in electrostatics. So there was a huge argument in physics. Okay. Now, during this journey of electrons, the electrons, they acquire so much energy. With that energy, they will move through the external circuit, loses their energy across the resistance and comes back. So the same thing continues. Now see, this is an electrolyte. Electrolyte means it will contain lots of positive ions, right? Now, during this journey of the electrons, they suffer collision with those positive ions of the electrolyte. As they suffer that collision, they lose energy. Is it okay? Energy loss ini. Ito laka potential do. 12 volt asido kusado ito. Kolibi dikiman by she? 8 volts. That means there is a loss of 4 volt potential, right? There is a loss in potential of how many? 4 volts. That potential has been lost by the electrons in this journey when they suffer collision with the positive ions of the electrolyte. Is it okay? So that obstruction offered to the electrons By who? By the positive ions of the electrolyte, by the positive ions of the cell. Is it okay? Is known as internal resistance. To itu laga journey do cell khan do internal resistance hoyasimita. There is an internal resistance. The electrons, the positive ions, they are obstructing the flow of electrons. So during their collision, in physics, collision is not hitting each other, okay? If the velocity, last year Smith and me, we discussed this one. If the velocity of one object changes due to the velocity of another object, if the momentum of one object changes due to the momentum of another object, that's collision in physics. In chemistry, biology, in maths, collision means you go and hit someone, that's collision. Okay? But in physics, collision means velocity of one object changes due to the velocity of another one. Momentum of one changes due to the momentum of another one. That's collision. So that due to this collision of the electrons with the positive ions, they lose their energy. That means they lose their energy means they lose their potential. So a potential of that 4 volt has been lost due to this resistance. Is it okay? That means the company was not lying. Was not the 12 volt ase? You can measure with the help of some instrument. No? Connect to khali external resistance till we can see that there is only 8 volt. That means there is a drop in 4 volts due to this internal resistance. Okay? So this obstruction offered to the electrons by the positive ions of the material of the cell is known as your internal resistance, and this internal resistance is denoted by small r. No? Now suppose if this internal resistance is 2 ohm, how much current is flowing? Practically 2 ampere, right? Current is 2 ampere. Then how much voltage is lost here? How much voltage is lost here? Current into resistance. V is equal to IR, Ohm's law. So that is 2 into 2. C. Is it okay? So 8 plus 4, 12 volts, which is the EMF of the battery. Alright, so this is what is known as your internal resistance. Is it clear to you? Is the concept clear? Yes. Any questions? You want to raise any questions? I think this is a very simple concept. Okay. Irido electrostatics laharo previous videos, part 1, part 2, part 3, we don't use that much concept over here. Okay. Yeah. So the obstruction offered to the electrons by the positive ions of the material of the battery, of the material of the cell, is known as internal resistance. Now let's see what is terminal voltage. Sabido, ito cell maintains a potential difference due to which electrons flows are forced to move through the circuit, across this resistance 4 ohm. There is a potential of how many volts? 8 volt, and the battery was supplying 2 ampere current. Is it okay? To battery laga pitori ki ase internal resistance thakishini. Now, in which there was a potential drop of 4 volts. Is it okay? Yes. External resistance tina. In the external resistance, in the external circuit, what is the potential? Terminal voltage. No? Once you start passing the current in the circuit, what is the potential across the external circuit? That is known as your terminal voltage, or terminal, we say terminal potential difference. Potential difference to voltage, yes or no? Potential difference is measured in volts, so a voltage only, so we call terminal voltage. Terminal voltage to kikobo, the potential difference between the two terminals of the cell acid, a resistance is connected across the 2 terminals. So the potential difference across the 2 terminals of the cell in a closed circuit, means when you start passing the current to the circuit, what is the voltage, okay, across your external resistance? That is known as terminal voltage or terminal potential difference. Very important topic, okay, this one. So, okay, I think that definition should do, okay. The potential difference across the two terminals of the cell in a closed circuit. Closed circuit means when current starts to pass through the circuit is known as your terminal voltage. Now you see once EMF of the cell. Now EMF of the cell minus the potential drop across this internal resistance. How much was that? 4 volt gives you the terminal voltage 8 volt. Correct? 12 volts means, don't write capital E, okay? E itu iliki no. 12 volts means EMF of the cell. Minus. 4 volts means potential drop here. Potential drop here. What was the internal resistance that we assumed? 2 ohm. We assumed like that in the example. The internal resistance was 2 ohm. How much current was flowing? 2 ampere, right? So 4 volts means, can I write 2 ohm into 2 ampere? Yes, na? Is equal to terminal voltage, capital V. Now, correct? E minus 2 ohm is internal resistance into the current, right? Is equal to, from another proof, example. But if you derive like this in exam, you will not get marks, okay? This is how we get. Now I'm going to derive it. Is it alright? Yes, but this is how we are supposed to work it out. No? Giti bro? Using this relation, you can find out terminal voltage, you can find out internal resistance, you can find out the current of the circuit, you can find out the EMF of the cell. So one of the most important relation in current electricity. One of the most important. You will always have a question based on this. Always. Okay? In the final examination. You can note it down later on. You have to note down from the very beginning. Okay? I think it will be very helpful. Now let us find out the expression that V is equal to, what did I prove? V is equal to E minus I. This is what we have proved, right? From the example. Now let us do it in the most correct way, the required expression. A cell having EMF, it always maintains a potential difference. Suppose A and B are the two terminals of the cell. Anything in between these two is inside the cell. Inside the cell we have internal resistance R. Okay. Suppose the battery supplies a current I to the circuit, then the current I flows from higher potential to lower potential. It will reach the point B. The same current will flow. Okay? Again and again. Now let us calculate what is the voltage if we follow the path from B to A. B para A tak path follow ko diba? Now we will follow a path from B to A, and we shall determine what is the potential at this point. We start from B, we will come to A, following this path, and we will see what is the potential at A. A the potential kiman hobo? External circuit iman hi potential hobo ni. Now the potential at A will be the potential that will be on the external circuit. Okay? Potential drop hobo la sekunde itu laga path bitor hobo do. Potential drop to idi hobo do. So let the potential at B be VB. let the potential at A be B. So we will follow this path from B to A and let us determine what is the potential at A. The potential at A will be the potential across the external circuit, terminal voltage. Correct? So it will be the V to VB whole way there. Okay? Alright? Yes. At B, what is the potential at B? VB. No? Yes. Well, when we follow this path, we will find out the algebraic sum of all the potential till we reach this point. That will be the potential at A. Algebraic sum of all the potentials across these 2 points will be the potential at A. Okay? So VB. Now, once B, we are starting from B, where VB is the potential. Now, as the current follows this path, reaches this point. Now, current itu point puncak itu P, itu Q dibo. When the current reaches the point P, then what happens? It will flow across this internal resistance, right? That means we know that current flows from higher potential to lower potential. Current flows from higher potential to lower potential. You don't know it? Huh? The current will flow across through this internal resistance, means it is flowing from higher potential to lower potential. So if the current flows from higher to lower, there is a drop in potential, right? Minus. How much drop in potential? Internal resistance is R, current I is flowing. How much drop in potential? IR. V is equal to IR, right? Yes. Now, once the current reaches this terminal, reaches this point, negative means lower potential, positive means higher potential. Now current is flowing from lower to higher, lower to higher. Is there a drop in potential or gain in potential? Gain in potential. Gain in potential. How much? How much? Equal to E. Gaining this much potential. And the algebraic sum of all this potential will be the potential at A. Are you getting that? Are you getting that? Yes. So we are finding the potential difference across these 2 points, right? Now, potential difference across these 2 points means final potential minus initial potential, right? Now, final potential minus initial potential. VA minus VB will be the potential across these 2 points. Higher potential minus lower potential, okay? Now what will happen? So VA minus VB will be equal to E minus IR, right? E minus IR, same thing. VA minus VB. Higher potential minus lower potential. Potential difference, terminal potential difference, right? So this is your E minus proved. Is it all right? Huh? Any problem that you want to discuss here? I can do so many things over here. Your potential of the V means terminal potential or potential in the external circuit. Potential in the external circuit means current into the external resistance. Correct? So this relation will become E minus I times small r is equal to I times capital R. E will be equal to IR plus I small r. I common R plus R. So E upon R plus R is equal to. Very, 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 very important relation. This is what I wanted to discuss today in the class. That's the end of the part 4 of this current electricity. Is it okay? Yes. Oh my God.